These are the 7 basic logic gates and their Boolean expressions. We'll go through each of these first and then take a look at how to express logic circuits using Boolean expressions. In Boolean algebra, an AND gate is equivalent to multiplication and an OR gate is equivalent to addition, and we'll take a look at why that makes sense in a bit. For the XOR gate, we use a circled plus. This is the XOR operator. The expression for the NOT gate is A negated. The line on top represents negation. The expressions for the NAND, NOR and XNOR gates are the same as the expressions for the AND, OR and XOR gates respectively, except the outputs are negated, so we draw a line on top like this. So why is ANDing two inputs together equivalent to multiplying them together, you ask? Well, suppose we have an AND gate with some input A and the input B we set to 1. A times 1 is A, so the output should be equal to whatever A is. And looking at the truth table, this is in fact the case. And if we set input B to 0, we get A times 0, which equals 0. So the output should be 0 no matter what A is. And the truth table tells us that this is also the case. So that's why we say that the AND gate performs logical multiplication of its inputs. So what about the OR gate? Why do we say that the OR gate performs logical addition? Well, let's go through the truth table. 0 plus 0 equals 0, no problems here. 0 plus 1 or 1 plus 0 equals 1, makes sense. And this might seem a bit strange, but in Boolean algebra, 1 plus 1 equals 1. That's just how Boolean algebra works. We only have zeros and ones to work with. You know that in normal algebra, the order of operations tells us that multiplication takes precedence over addition, and this actually applies to Boolean algebra as well. When you want to take a Boolean expression and draw the circuit that it represents, you have to remember that AND comes before OR. So if we take the expression A and B or C and D, we AND A and B together and C and D together first, and then OR those two outputs together. But what about XOR gates? Does XORing come before or after ANDing? Well, the thing is, there's no convention that's universally agreed upon, and different programming languages have different orders of operation when it comes to Boolean expressions, so that's why it's always a good idea to use parentheses to avoid any confusion. Now let's talk about how to find the Boolean expression of a logic circuit. For simple circuits, it's usually not too difficult to figure out the expression in your head. If we go from right to left, we see that Y is equal to two signals ANDed together. The first signal is A ORed with B, and the second signal is C ORed with D with a NOT gate at the output, so we negate this by writing a line on top. And finally, when these two signals get ANDed together, we end up with this expression. But what if you have a more complex circuit? With a circuit like this, it's easiest if we start from the left side and go step by step towards the right. And at each point, we'll write the expression for that specific point. At the bottom we have A ANDed with B, and after the first XOR gate we have A XORed with B. So we get C ANDed with this signal from up here, and we use parentheses to make it clear that the XORing happens before the ANDing. And now we see that the expression for the output X is this signal XORed with C. And the expression for Y is these two signals ORed together, so we get this expression. There's a law in Boolean algebra that says that we can get rid of the parentheses in the expression for X. And there's actually a long list of laws in Boolean algebra that can help you simplify expressions, but that's for another video.